let us go on to consider the various steps involved in evaluating the discrete convolution using the graphical method. Hence, the first step is, let us substitute n equal to 0 in the expression of y of n. So, the expression becomes y of 0 is going to be equal to x of k into h of 0 minus k, which is basically x of k into h of minus k. Hence, the basic things required for understanding this problem would be, first, represent x of k. Let us represent x of k in the conventional manner. Hence, this would be, at n equal to 0 it is 5, at n equal to 1 it is 1, at n equal to 2 it is minus 2, and at n equal to 3 it is 4. This is the basic representation of x of k, which is our first part of the problem. Next, let us try to represent h of minus k. Before representing h of minus k, let us try to represent h of k. Hence, h of k is given by, at n equal to 0 it is 1, at n equal to 1 it is 2, and at n equal to 2 it is 3. What about h of minus k? By now we are quite familiar with what happens when we want to represent h of minus k. It is a flipping action or a time reversal action or shifting whatever is in the positive time axis to the negative time axis. So let us analyze what happens for h of minus k. For h of minus k, we will be having, at n equal to 0 it will be 1, at n equal to minus 1 it will be 2, and at n equal to minus 2 the value would be 3. So we have represented the first two cases, which means we have completed representing x of k and h of minus k. Next, only the convolution is left. What is this convolution? Let us try to now represent y of 0, which would be equal to x of k into h of minus k. So, just rewriting the steps for x of k and h of minus k, we would be getting this as, this is x of k and this is h of minus k. So, we have 5, 1, minus 2 and 4, and on the other side we have 1, 2 and 3. So, the answer would be multiply and add, which means 5 into 1, and if you have other values at these points, we need to add them. Since we don't have the values, the answer is just multiply and add, multiply, and the solution is obtained. The addition is not required in this case, so y of 0 is going to be equal to 5. Let us go on to the second case where n is going to be equal to 1. When n is going to be equal to 1, we get the expression as y of 1 is going to be equal to x of k into h of 1 minus k. The representation of x of k remains same, hence it is not discussed again. Let us go on to see how h of 1 minus k would be represented. If this is understood, the entire process of discrete convolution becomes very simple. H of 1 minus k could be written as, one part which we have already got is h of minus k. Going on similar means, we could represent it as h of minus of k minus 1, which gives us h of 1 minus k, which is the same as what is given here. This is exactly what we would like to do. So, let us go on to recall that h of minus k was represented by, at n equal to 0 it was 1, at n equal to minus 1 it was 2, and at n equal to minus 2 it was 3, which means there was a flip from 0 1 2 to 0 minus 1 minus 2, which gave us the answer of h of minus k. Now our problem is, how do we get h of minus of k minus 1? For doing k minus 1, which is already the subtraction of h of minus k, we would just like to shift what has been obtained for h of minus k towards the right. So, what we have done is, what was available at 3, at minus 2 has gone to minus 1, what was available at minus 1 has gone to 0, and what was available at 0 has been shifted to 1. which means we have shifted. If we see n minus 1, we usually shift it towards the right. The same thing has been implemented here. So we have got it as 3, 2 and 1 at minus 1, 0 and 1 respectively. So let us go on for our third step, which is the evaluation of y of 1, which is given by x of k into h of 1 minus k. So here x of k is given by 5, 1, minus 2 and 4 at 0, 1, 2 and 3. Hence, the value here is at 0 it is 2, at 1 it is 1, at minus 1 it remains as 3. So we are multiplying these two. 5 into 2 it is 10. Similarly 1 into 1 is 1. So we have got two values, 10 and 1. The solution of y of 1 will be the summation of each of these multiplied products, which gives us the answer as 11, which is 10 plus 1. Let us go on to the next case where n is equal to 2. When n is equal to 2, the expression becomes y of 2 is going to be equal to x of k into h of 2 minus k. As usual, the first process is represent h of k, next process is represent h of 2 minus k from h of 1 minus k, and then multiply and add if necessary. Going by similar grounds, x of k is represented as at n equal to 0, 5, at n equal to 1, 1, at n equal to 2, minus 2, and at n equal to 3, 4. Previously, we have already got what is the value of h of minus k minus 1. Let us just analyze what we had got previously. So, at n equal to 1, it was 1, at n equal to 0, it was 2, and at n equal to minus 1, it was 3. Now, what we require to obtain is h of minus k minus 2. This would be obtained by shifting this, as in the previous case, to the right by a magnitude of 1. Hence, 3 which was available at minus 1 now comes to 0, 2 which was available at 0 now comes to n equal to 1, and 1 which was available at n equal to 1 now comes to 1. So, rewriting, we get the expression at n equal to 0, 1 and 2 as 3, 2 and 1. So, let us rewrite that x of k is going to be at n equal to 0, n equal to 1, n equal to 2 and n equal to 3, it is 5, 1, minus 2 and 4. Similarly, here h of minus k minus 2 at n equal to 0 is 3, at n equal to 1 it is 2, and at n equal to 2 it is 1. So, our answer will be 5 into 3 is 15, 1 into 2 is 2, and minus 2 into 1 is 1. So, when we sum up all these, the answer is these two get cancelled, and hence our final answer is y of 2 will be equal to 15. Next, let us go on for the next case where we need to consider for n is equal to 3, which means our expression is y of 3 is going to be equal to x of k into h of 3 minus k. As usual, let us represent h of k, let us represent h of 3 minus k, and then multiply and if necessary add. So, x of k as usual is at n equal to 0 it is 5, at n equal to 1 it is 1, at n equal to 2 it is minus 2, and at n equal to 3 it is 4. Now let us try to represent h of 3 minus k. On similar grounds, what we would be getting is, we have already got h of minus k minus 2 in our previous problem. I am just considering it again. So at n equal to 0 it was 3, at n equal to 1 it was 2, and at n equal to 2 it was 1. So h of minus of k minus 3 would be again one step on the other side. Hence it becomes at n equal to 1 it is 3, at n equal to 2 it is 2, and at n equal to 3 it is 1 respectively. Now let us try to get the final answer, which is going to be y of 3 is going to be equal to x of k into h of 3 minus k. So rewriting, at n equal to 0 it is 5, at n equal to 1 it is 1, minus 2 and 4, and here at n equal to 1 it is 3, at n equal to 2 it is 2, and at n equal to 3 it is 4. The value at 0 does not exist here, so here also we do not have a value at n equal to 0. So multiplying 3 minus 4 and plus 4, so when we add this, minus 4 and plus 4 get cancelled. So our answer for h of k into x of k into h of minus k minus 3 would be y of 3 is going to be equal to 3. Let us go on to our next value of n, which is the next consecutive value, which means n is equal to 4. At n equal to 4, we get the expression as y of 4 into x of k will be equal to x of k into h of 4 minus k. This is obtained in a similar manner as in the previous case. Represent x of k represents h of 3 minus k. From h of 3 minus k obtain k minus 4 minus k, and then write the respective values, multiply and add. Let us start the first case, which is going to be represent x of k. As usual, the value of x of k would be at n equal to 0 5, at n equal to 1 1, at n equal to 2 minus 2, and at n equal to 3 4. Let us go on to consider the most important part, which is the second part, representing h of 4 minus k. This is obtained by considering 4 minus k as minus of k minus 4, as in the previous case where we consider h of 3 minus k as h of minus of k minus 3. Hence, in the previous case we are just rewriting the results which we got. It would be at n equal to 1 it was 3, at n equal to 2 it was 2, and at n equal to 3 it was 1. So what happens when we shift again one more value to the right? Hence this would become what is available at n equal to 1 goes to n equal to 2, what is available at n equal to 2 goes to n equal to 3, and what was available at n equal to 3 goes to n equal to 4, which means we have the values from 1 to 3 which was there for h of minus k minus 3 now becomes from n equal to 2 to 4, as is shown here, 3, 2 and 1. What happens in our next case, where we would like to evaluate y of 4 is going to be equal to x of k into h of 4 minus k. This is written as at n equal to 0, 1, 2 and 3. The values are 5, 1, minus 2 and 4, as is given for x of k. For h of minus k minus 4, it is at starting only at 2. So at 2 it is going to be minus 2 in this case. So here it is 3. So this is 3, this would be 2, and at n equal to 4 we still have 1. So the product is 3 into minus 2 is 6, 4 into 2 is 8. When we sum 8 minus 6, y of 4 gives us 2, which is the solution for x of k into h of 4 minus k. Next, let us go on to our next discussion, which is going to be for n is equal to 5. When n is going to be equal to 5, we have the expression as y of 5 is going to be equal to x of k into h of 5 minus k. The three steps we need to recall is represent x of k, represent h of 5 minus k, multiply them, see if there is an addition required, add them and give the result. So representing x of k is as usual 5, 1, minus 2 and 4 at 0, 1, 2 and 3. Represent h of 5 minus k, which would be got from the previous case as h of minus k minus of k minus 4 would be given by h of minus of k minus 5. Hence, if we recall, at h of minus of k minus 4 was at n equal to 2 it was 3, at n equal to 3 it was 2 and at n equal to 4 it was 1. So, for h of minus of k minus 5 it will again be shifted one position, so it will be 3 at 3, at 4 it will be, the value would be 2 and at 5 the value would be 1. Hence, let us go on to see what would be the answer for y of 5 will be equal to x of k into h of 5 minus k. The answer would be this value multiplied by this particular value. Note that h of minus k minus 5 starts only at n equal to 3, which means it starts only at 4. This is what has been represented here. 5, 1, minus 2, 4 is going to be 3. At 3 it is 4. Here also at 3 it is 3. At 4 it is 2 and at 5 it is 1. So the answer would be 4 into 3, 12. So y of 5 would be 12, which means x of k into h of minus of k minus 5 would be 12. Let us go on to our next case, which is going to be at n equal to 6. Since we are going in a sequence, let us also proceed this in a sequence. Since we have finished up to n equal to 5, let us move on to n equal to 6. So, for n equal to 6, y of 6 will be x of k into h of 6 minus k. Representing x of k in a normal manner, it would be at 5, at n equal to 0 it is 5, at n equal to 1 it is 1, at n equal to 2 it is minus 2 and at n equal to 3 it is 4. Similarly, representing h of 6 minus k from h of minus k minus 5 would be, previously it was 3, 2 and 1, now it becomes 3, 2 and 1 at 4, 5 and 6. So now when we try to multiply, kindly note that at x of k it ends with n equal to 3 and h of minus k minus 6 starts at 4, which means there is no overlap. There is a gap between 3 and 4. Hence, the answer is 5, 1, minus 2 and 4 at n equal to 0, 1, 2 and 3. And at 4, 5 and 6 we have our values of h of minus k minus 6, which is 3, 2 and 1. Hence, our net answer is 0. Any value beyond n equal to 6 is definitely going to result in the same value 0. Let us go on to consider one more example on the other side of n, that is, what happens when n is equal to minus 1. When n is equal to minus 1, we have y of minus 1 would be h of k in x of k into h of minus 1 minus k, which means x of k into minus 1 minus k. As usual, let us try to represent x of k, which would be at 0, 1, 2 and 3, it would be 5, 1, minus 2 and 4 for x of k. There is no change in any of the representations of x of k. Let us go on to see what would be h of minus k plus 1. This would be given by, h of k is given by, at n equal to 0 it is 1, at n equal to 1 it is 2 and at n equal to 3 it is 3. We remember that h of minus k is 1, 2 and 3 here. So please note, since it is a plus 1, which means it is going to be shifted on the negative time axis, it is shifted on this side instead of the other side, which we have discussed so far. because there was a negative sign so far. Now we have a positive sign, so it is shifted towards the left, which means it becomes at -1 it becomes 1, at -2 it becomes 2, and at -3 it becomes 3. So our answer is going to be 5, 1, -2 and 4 at n equal to 0, 1, 2 and 3. At -1 it is 1, at -2 it is 2, and at -3 it is 3. Hence our net result is 0, which means at any value beyond n equal to 0, the value of the convolution is going to be 0. Hence we have got that y of -1 is going to be 0, as can be seen in this particular case. Let us now try to summarize the results that we have got for various values of n starting from -1 to 6. It was observed that when n is less than 0, that is at -1, the value of y of n is 0. So it was concluded that at any value beyond -1 also, the value of y of n would be equal to 0. Similarly, it was got that at n equal to 0 it is 5, at n equal to 1 it is 11, at n equal to 2 it is 15, at n equal to 3 it is 3, at n equal to 4 it is 2, and at n equal to at n equal to 5 it is 12. That means we had got the values of y of n to be finite values between 0 to 5. Also, it was analyzed at values equal to 6 and greater than 6. At equal to 6, it was observed that y of n equal to 0. Hence, a conclusion was made that at any value beyond 6 also, the value of y of n would be 0. This is an important understanding of the entire process of convolution.